A 143 gram baseball going 39 meters per second is caught by the catcher, hopefully, right? In stopping, the ball travels 7.5 centimeters, presumably in that direction, right? What is the average force exerted on the ball? I think this is going to be a Suvat first, right? So let's do that. I should make my U's look different from my A's, I feel like. Okay, so let's see. It's going 39 and it stops, right? So 39 and 0. And then the displacement is 0.075 meters. Because notice it's centimeters, right? And then I'm going to use, I guess, no t, right? So v squared plus 2as. Okay, so 0 squared is 39 squared plus 2 times a that we don't know times 0.07. And you can see this number being small makes this number big, right? 39 squared divided by 2 divided by 0.075 is, wow, that's a big acceleration. The acceleration is 10,140 meters per second squared. And I'll bet that baseballs stop in less distance than that, which is why they kind of hurt. Okay. You got to have that thick glove, right? Okay, so now we're just going to F equals ma this, right? Did anybody notice grams? Oop. So this is, the mass is 0.143 kilograms. That's about like the mass of a baseball, right? So our force is equal to 0.143. That, by the way, that devilry was, I just divided by 1,000, right, to get kilograms. Times, so this is not that big, but this is a whopping force, right? Oh yeah, that's his negative. Look at that, because it slows down. I miscalculated that. Minus 10,140. Okay, so times, and I get that the force is negative 1450 newtons. It's 1450.02 is what it is, which is crazy. All right.